Hello everyone. We will be solving this equation. To solve this equation, we will be making three cases. So it is a very simple question. It is not a very difficult question. The only thing in this is that we were going to play with the equations instead of solving the equations. And while playing with the equation, we'll get to the desired result of x square by bc minus f square is equal to y square upon ca minus g square equal to z square upon ab minus h square. Now, how to play with the equations? There are three equations, right? So we will make the pairs. Firstly, we will make a pair of first and second equation. Secondly, we will make a pair of second and third equation. And at last, we will make a pair of first. At last, we will make a pair of first and third equation. As we will make the pairs, we will get the ratios, and while solving the ratios, we'll get our answer. So let's continue with it. Uh, First two equations. The first two equations are solution case 1, where we are taking the equations ax plus hy plus gz is equal to 0 and hx plus by plus fz equal to 0. Now this is a two equations and three variables. So, as discussed previously, it is not feasible for us to solve the values, or it is not feasible for us to get the values of x, y, and z, but we can calculate the ratio between x, y, and z. So, we can calculate the ratio, but before calculating the ratio, we need to convert this three variable problem to a form of two variable. So, let's divide it by z, ax plus hy plus gz is equal to 0 divided by z, and similarly hx plus by plus fz divided by z is equal to 0. The further it gets simplified, it could be written as a into x upon z plus h into y upon z plus g is equal to 0, and the second equation could be written as h into x upon z plus b into y upon z plus f is equal to 0. Now we will be taking the values of a1, a2, b1, b2, c1, c2, and then substitute those values in the formula x upon b1, b2, c1, c2 is equal to y upon. This we have discussed in the previous videos, right? If you want to watch it, you can go and watch it. C1, C2, A1, A2 is equal to Z upon A1, A2 and B1, B2, right? How this formula came, how we are going to solve uh, through this formula, this all has been covered in the previous videos, and I've even discussed some interesting examples. If you want, you can go and watch it. So let's continue with it. The values of A1 is A, of B1 is H, of C1 is G, of A2 is H, of B2 is B, and of C2 is F. I'm just taking the values from here, right? I'm taking the values from these two equations. Okay, so now we will substitute the values as x upon B1 by B2, or B1 which is H upon B, and it becomes C1 C2 which is G upon F is equal to Y upon G upon F and A upon H, and it becomes Z upon A upon H, and it is H upon B. We can solve it with the help of cross multiplication as the name suggests. So multiplying them diagonally or cross multiplying them, we can get our answer in the denominators, of the denominators. So x upon hf minus bg is equal to y upon gh minus af is equal to z upon ah minus a ab minus h square. We will name it as our equation number 1. We will name it as our equation number 1. Now we'll take the other two equations which are present in the in our equations or in our questions, right? This is the equation GFC. Okay, this is the equation. So these two equations are there now. Now again the same method that we have done in the case 1, we will be doing for the case 2 as well. So it will become hx divided by the variable, by any one variable, let's say for z. So ahx by plus fz divided by z is equal to 0, and gx plus fy plus cz divided by z equal to 0. So we will be getting h x upon z plus b, sorry, y upon z plus f is equal to 0, and another equation as g x upon z plus f y upon z plus c is equal to 0. Now again the same process, we will be calculating the ratio between x, y and z for these two, for this pair of equations, and for that we need a1, b1, c1, a2, b2 and c2, right? And substitute these values in the formula: x, a1, b1, b2, c1, c2, y, c1, c2, a1, a2, z, a1, a2, b1, b2, right? So we need to get the values. So a1 is equal to h for the second case. I'm writing this for the second case, right? As you might be continuing with the video. A1 h, b1 is b, and c1 is f, a2 is g, b2 is f, and c2 is c. Now we will substitute the values. So we can say x upon b upon f, then c1 c2 which is f upon c is equal to y upon f upon c, h upon h upon g is equal to z h upon g and b upon f. As the name suggests, cross multiply. We will multiply them diagonally. I've repeated this multiple times. So, okay. So this will become as x bc minus f square is equal to y fg minus ch is equal to z hf minus bg. We will name it as our equation number 2, right? Now we will be taking the third pair of equations. We will be taking the third pair of equations. Okay. So we have taken the third pair of equations, which is the first equation and the third equation. Now we will solve these equation. Again, we will reduce it into a two variable problem. A x upon z plus h into y upon z plus g is equal to 0, and it will become g x upon z plus f y upon z plus c is equal to 0. We will be solving these equations with the help of cross multiplication method, and use the cross multiplication method, right? Uh, Firstly, we'll write the formula. The formula is x b1 b2 c1 c2 is equal to y c1 c2 a1 a2 is equal to z a1 a2 b1 b2. So we need to get the values of a1 b1 c1 and a2 b2 c2. So a1 comes as a, b1 comes as b1 comes as h, c1 g, a2 is g, b2 is f, and c2 is c. Now we will substitute these set of values in the formula to get our desired answer, or to get our equation, and then we'll continue with the solution. So it becomes x upon b1 b2 h upon f and c1 c2 g upon c is equal to y upon g upon c, and it becomes a upon g is equal to z upon a upon g and h upon f, right? Now, as the name suggests, cross multiplying, so we will cross multiply them, and after cross multiplying we will get x upon hc minus fg is equal to y upon g square minus ac is equal to z upon af minus gh, and we'll name it as the equation number third. Now I'm writing down all the three equations at once so that we can play with it and get our desired result which we want to prove. Yes, so now I have written all the three equations, and after writing all the three equations, what I observe, or what I'm observing, is that g square minus ac, here it is bc minus f square, and here it is ab minus h square. So the only thing which we have to do is we have to take or consider the values z upon ab minus h square, x upon bc minus f square, and y upon g square minus ac to the other two ratios in each respective equations. What I mean to say is that now we need to prove this set of form of equations. So what can we do? We will start with x square upon bc minus f square. So x square upon bc minus f square, that will be x multiplied by x into bc minus f square. Now if we get the value of x upon bc minus f square, how could we get this value? We know that x upon bc minus f square is nothing but x upon bc minus f square is nothing but y upon fg minus ch. Y upon fg minus ch. I've already drawn this. So y upon fg minus ch. So I can say x into y upon fg minus ch and y upon fg minus ch using 2. I can say this I have written using equation number 2. Now x into y upon fg minus ch, it could be further written as it could be further written in the form as x upon fg minus ch into y, or we can say minus of x. I'll explain why I've put minus, and just alternate the values in the denominator of the fraction x upon fg minus ch, which becomes ch minus fg into y. Right? Now I can say now I can say that x upon hc minus fg, this part, x upon hc minus fg is equal to y upon g square minus ac. So I'll substitute the values. So I've drawn this. Now minus x upon ch minus fg into y. X upon ch minus fg is nothing but x upon ch minus fg is nothing but y upon g square minus ac. So I can write this as g square, sorry, not g square. I can write it as y upon, keeping the minus sign, g square minus ac into y, or minus of y square upon g square minus ac, or just uh, dissolving the minus sign again in the equation in the denominator, y square upon ac minus g square. And this I have written this I have written using third equation. Right? Now we'll continue with y square minus ac. So y square upon ac minus g square. Sorry for that above. Not, it's not y square upon ac. It's not y square minus ac. It's y square upon ac minus g square. This can be written as y into y ac up minus g square. Now, what value is y upon ac minus g square equal to? So we know from equation number third, that y upon g square minus ac is z upon af minus gh. It is equal to z upon af minus gh. So we can write it. So we can write it as y into z upon minus of z upon af minus gh. I have put minus because in the third equation g square is first and it is subtracting ac, whereas in the given equation ac is first and subtracting g square. This I have written using again third equation. Now, uh, this part is written. Now we will dissolve this minus sign. So what I can say is y z upon, or let's keep it minus only, af minus gh, right? Now what is, it could be further written as y upon af minus gh into z, and I have put the minus sign with the y. What is the value of y upon af minus gh equals to? We will use the equation number. Let's see, where do we get this value? We'll get this value here, y upon hg minus af, right, is equal to z upon, is equal to z upon ab minus h square. So I can write it as, dissolving the minus sign, y upon hg minus af into z, and this is equal to, and this is equal to z upon ab minus h square into z, or z square upon ab minus h square. Hence proof. Uh, we have used here using 1, right? So this is how we have achieved. We have moved from x square upon bc minus f square. Then we have proved y square upon ca minus g square. Then we have proved z square, it equal to z square upon ab minus h square, right? So this is how we have proved, and we can say hence. My name is Prakhar Jain. If you like this video, give a thumbs up. Thank you.